Hi, students. Let's take a look at how to draw Lewis structures. I do want to point out that this is going to be for covalent compounds. So we're looking at things that are molecularly bonded. Okay, we are looking at nonmetals. Okay, if you see a metal up here, then it might be ionic, and that's a different system here. Okay, so first of all, the rules that we're going to follow as we go through this, the first thing we're going to do is total our valence electrons. Friendly reminder, we can determine valence electrons from the periodic table. So if you have a periodic table like this one here, and you want to do the valence electrons, everything in this group has 1, everything here has 2. We skip these, everything here has 3, 4, 5, 6, 7, and 8 valence electrons. Those are the electrons in the outermost energy level, and we need to total those. Now, sometimes we have a compound that has a charge to it. We have to take that charge into consideration when we're totaling our valence electrons. That charge, if you have a positive charge, then you have actually lost electrons. So we would subtract a positive charge. If you have a negative charge, you've gained electrons, and we're going to add the negative charge. We will see some examples in just a minute. But the second thing I'm going to do is I'm going to arrange my atoms. Typically, if carbon is present, it goes in the middle. And then if whichever atom you have the least of would go in the middle if there's no carbon present. Okay, and then we're going to complete the octets. Most of the elements that we're dealing with want to have 8 electrons when we're done. So we're going to be completing those octets. There are some exceptions. Hydrogen is so tiny, only has 1 energy level. Hydrogen can only have 2 electrons. And then boron. Boron is usually content with 6 electrons. Okay, so those are some exceptions that we're going to see. And then the last thing we're going to do is we're going to compare what we have drawn to what we have calculated over here with our valence. Okay, so we're comparing these two things. If they do not match, if you have drawn too many electrons compared to what you should have had with according to your valence calculation, we're going to be making double and triple bonds. Okay? Or if you need more electrons, they're going to go on the central atom. Let's look at some examples. Okay, so first of all, the Lewis structure for H2O. The first thing that I'm going to do is I'm going to calculate my valence electrons. So we're looking at H2O. That has it has 2 hydrogens. I go look at my periodic table. Hydrogen has 1 valence electron. So 2 times 1 is 2. And then it has 1 oxygen. Go look at the periodic table. Oxygen has 6 valence electrons. So 1 times 6 is 6. Right, so I'm adding these two things together. I get 8. There's no charge. So 8 is my total number of valence electrons. Now, I'm going to start arranging my atoms. I don't have carbon, so whoever I have the least of is going to go in the middle. I'm going to have an oxygen in the middle with a hydrogen on each side. Okay, so I've got an oxygen in the middle bonded to a hydrogen on each side. Next, it says to complete your octets. Okay, so hydrogen's one of our exceptions. Hydrogen can only handle having 2 electrons. This bond counts as 2 electrons. A covalent bond is a shared pair of electrons. So each one of these bonds is 2 electrons. When I'm counting like this, that's like having 2 for hydrogen and 2 for oxygen. It is shared. So each of my hydrogens already has 2 electrons. My oxygen wants 8. It's kind of a normal atom. It wants an octet. It wants 8 electrons. Right now, my oxygen has 2, 4. I'm going to draw 6, 8. Okay, so I've completed octets. The last thing I need to do is compare what I have drawn to my number of valence electrons over here. So I'm going to be counting all the electrons up here. Bonds count as 2. And so when I go to count, I've got 2, 4, 6, 8, which matches 8. This is the correct Lewis structure for H2O. Just a little note, it's not showing bond angles correctly, but it is the correct Lewis structure for H2O. All right, let's look at another one. We're next going to do one that has a charge, CO3 with a charge of -2. So the first thing I'm going to do is I'm going to calculate my valence electrons. I'm going to find carbon on the periodic table. carbon's right here. I would have my periodic table numbered all the way across. And so carbon has 4 valence electrons. Okay, so carbon has 4. I have 1 carbon with 4 valence electrons. That's 4. Oxygen, when I look at oxygen, oxygen is right here. It has 6. I have 3 oxygens. Each one has 6 valence electrons. 6 times 3 is 18. All right, and then I'm going to add those together, and I get 8 plus 4 is, this is going to be 22 right here. But I'm not quite done because CO3 with a charge of -2 has a charge of -2. When you have a -2 charge, you have actually gained electrons. Electrons are negative. So because it's a negative charge, I'm going to add right here. When I'm done, I should have a total of 24 electrons. Okay, so this is, at this point, I had totaled my electrons. I'm ready to start drawing. Carbon's present, so carbon goes in the middle, and then I'm going to put 3 oxygens around it. You could put them on either side. This is just what I've chosen to do. And now I'm going to complete octets. All of the atoms up here want to have 8 electrons. Okay, so when I look at oxygen right here, it currently only has 2. That bond counts as 2. So 4, 6, 8. This one has 2, 4, 6, 8. This one has 2, 4, 6, 8. And then my carbon currently has 2, 4, 6. It needs 2 more. That gets carbon up to 8. Okay, so at this point, I have completed my octets. The last thing I need to do is compare what I have drawn to the number of valence electrons I should actually have. So I'm going to count everything up here. Bonds count as 2. So I'm starting right here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So I've drawn 26, and I need to have 24. So my slide a minute ago said if you have too many, we're going to make double or triple bonds. So I need to show you how to make a double bond. So first of all, I could really put this double bond in any of these places right here. Okay, I'm just going to pick one. Okay, I'm going to be putting my double bond right here. When you go to make a double bond, you're going to take a pair of electrons away from the atom on both sides of the double bond. So I'm going to be taking away this pair and this pair. And I'm taking away 2 pairs to make the one double bond. When you're done making a double bond, your number of electrons should have shrunk by 2. Okay, so once again, I'm taking away this pair and this pair, and I'm making a double bond. Now I'm going to recount. When I recount, I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, matches 24. This is the correct Lewis structure for carbonate, CO3 with a charge of -2. I will point out that for ions, we typically will put them in brackets and put the charge on the outside. Okay, but that's it. That's the Lewis structure. This one had a double bond. All right, I have another one up here. We're going to do HCN. Okay, HCN, the first thing I need to do is total my valence electrons. I have 1 hydrogen. It has 1 valence electron. I have 1 carbon, has 4 valence electrons, and I have 1 nitrogen, and I believe, I'm going to go check, that it has 5 valence electrons. Let's see, nitrogen's right here. We would 1, 2, 3, 4, 5. Yes, nitrogen has 5 valence electrons. I total those up. I should have a total of 10 when I'm done drawing. Okay, so now I'm going to start arranging my atoms. Carbon's present, so I'm going to put carbon in the middle, a hydrogen on one side, and a nitrogen on the other side. A little fun fact, you could not have put hydrogen in the middle. Hydrogen cannot handle 2 bonds. It's just too small. Okay, so I've arranged my atoms. I put carbon in the middle. Now I'm going to start completing octets. Hydrogen is already done. Hydrogen wants 2. It has 2 from that bond. This carbon right here would like to have 4. It's just a normal atom. It wants 4. So 2, 4, 6, 8. This nitrogen would also like to have 8. It currently has 2. So 4, 6, 8. Okay, now I'm going to look and see if what I have drawn matches my number of valence electrons. What I have drawn is 2, 4, 6, 8, 10, 12, 14. Okay, I have too many electrons. So I'm going to start by making a double bond. Okay, I cannot make a double bond here. Hydrogen cannot sustain a double bond, and there's no electrons for me to take away from it to make that double bond. So I'm going to have to make it here. Okay, so when you make a double bond, you're going to take away 2 electrons from each side. So I'm going to be taking away these 2 and these 2. Take those, and boom, there's my double bond. Then I'm going to recount. When I recount, I have 2, 4, 6, 8, 10, 12. So making my double bond dropped my electrons by 2, but I'm still not where I need to be. Okay, so I need to make another bond. In this case, I can't make it here. I can turn this into a triple bond. So I'm going to take 2 electrons away from both sides. I'm taking 2 from here and 2 from here and making a triple bond. Okay. So once again, I've got 2, 4, 6, 8, 10 matches 10. And I just want to point out that when you are done with an appropriately drawn Lewis structure, your valence electrons are going to match. That's what we've just confirmed. And everyone is still going to have a completed octet. Hydrogen still has 2, carbon still has 2, 4, 6, 8, and nitrogen still has 2, 4, 6, 8. So we still have completed octets, and we still have the right number of electrons. So this is a good Lewis structure. Okay, and I have one more. This is SF6. Okay, I wanted to show you one that has what we called an expanded octet. Okay, so an expanded octet is when something can have more than its octet. You have expanded the octet. What happens here is if you deal with elements that are in period 3 or below, okay, period 3 or below, these guys all have an empty D subshell. Okay, so when you start doing electron configurations, you're going to see your D subshell. So these guys all have an available D subshell that they can stick some electrons into. So any of these, period 3 or below, can have more than 8 electrons. If you're in period 1 or 2, you cannot have more than 8 electrons. But period 3 or below, you can do what I'm about to do next. Okay, so first of all, I'm going to total my valence electrons. I have 1 sulfur. It has 6. Okay, so 1 times 6 is 6. All right, and then I have, for fluorine, I have 6 fluorines. Each one of those has 7. Okay, I am putting that in my calculator, guys. Just don't judge me. I got 42. When I add those together, I'm getting 48. Okay, so I need to have a total of 48 valence electrons when I'm done here. Okay, so my next step is I'm going to put sulfur in the middle. This is going to look a little weird. I'm going to put sulfur in the middle, and then I need 6 fluorines around that sulfur. Fluorine here, fluorine here, fluorine here, fluorine here, fluorine here, and I believe that's my last fluorine. Okay, so there should be 6 fluorines around that sulfur. Okay, that's okay. This right now, I'm already seeing sulfur has an expanded octet. Sulfur has, right now, I've got 12 electrons on that sulfur, and most things want 8, but that's okay because sulfur's in period 3 or below. All right, the next thing I want to do is I want to complete everyone's octet. Okay, so sulfur's done. Sulfur's completed. Fluorine needs to have 6 more electrons on each one of them. Okay. Draw all these guys in, and then we're going to count them. Let's count these guys. I'm going to start at the top. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 46, 48, 50. Okay. I feel like I counted something wrong. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 46, 44, 46, 48. I'm good at chemistry, not always at counting. Okay. This matches. That's more what I was expecting. We got our 48 here. which matches our 48 here. And now you've seen an example of an expanded octet. The one thing I don't feel like I showed is what if you have more here than you do over here. Any extra electrons would go on the central atom. And a central atom, as long as it's in period 3 or below, can have those extra electrons can be like a pair of electrons. Like if, let's say, this is not necessary for this particular one, but if we had needed to put a pair of electrons right here, that's okay for sulfur because sulfur's got an expanded octet. Okay? So I hope this helps. Good luck with your Lewis structures.